We got 2 more 7-day periods to move. So I need to see your ministers. And I'll talk to y'all later. All right. So now we know who and what are you is from lectures from Malachi York. Right. So now we're gonna go deeper to show. First, we're gonna show the human as a mammalian hybrid reptilian. All right. So pull up alligator spine versus human spine. See the rib cage?
Now
you see how small the hips is, right?
Yeah.
Okay, so in the human species, when the woman have reptile hips, it's called closed hips. And they narrow like this. All right. Now, when you get to the head, something remarkable happens in the change. But at the bottom of the spine, you see that beyond the spine, you got more vertebrae. In the human, everybody think it's a primate condition, but it's actually a reptile condition. It's called an elongated coccyx. Right? So pull up the coccyx so they can see what I'm talking about. You can use that when it don't matter. I just wanted to see what the elongated coccyx looked like. It looked like a tail. Right? So in the human, it's supposed to be what you call a vestige organ. It's supposed to have been bred out of the DNA. It's not supposed to, it's not a common trait in the human design, but it's a reptile trait. Right? Now, when we get to the head, from the tail, we'll find that we have, if you put in reptilian brain.
Hey, Rob, Bob here in the building, man. We going lit. All right, which one you want? This
click on the second one and see what that says.
R complex. All right. Let me blow it up.
Yeah, that's the one.
Let me blow it up.
Now, we're gonna notice our brain is in 3 layers. The first one is called your reptilian brain. Right? Your limbic brain or your midbrain is actually called your old mammal brain. We're gonna pull that up next.
All right.
And then your neocortex is called the new mammal brain. So pull up old versus new mammal brain.
All right, let me see. Can I get a
try the first one?
Okay, the first one. It ain't gonna let me say that one. Damn.
No, it don't say mammal brain.
It says it's got like a different, hold up. Let's pull this up. Let's do this one. New brain, primitive brain.
That's how they labeling them now, new brain and primitive brain.
Hold on, let me do it. Hold on. This right here might be a good one. This right here might be a good one right here. Yeah, I think this one might be a good one. Where is it at? Where is it at? Right here. This right here might be a good one. Let me blow it up. Is that a good one?
They're showing different types of brains.
Okay, hold on.
But look.
Let's see. Let's see. What about?
All right, we're gonna do it this way. Ask
this one. Or is it
ask the question to go to the main Google page. We're gonna have to read it.
Okay, okay, yeah. Let me go back.
So ask, what is the old mammal brain in humans is the question.
Got it right here. Let's give it a second. Rob out to everybody in the building, man. We live, we lit. Okay, okay. Birds and mammals have brains that are up to 10 times larger relative to the body size. Then those are reptiles and other animals. Why some researchers have proposed that the early nocturnal mammals evolved larger brains to boost their hearing because sight with less importance at night. Okay. In fact, if we put the brain or different mammals next to each other, the similarities are easy to spot, even though the brain varies a lot in their size and in their fold, they all have the same parts. All these brains have cerebral cortex and cerebellums and a brain stem. Okay, try to find a good picture to go with it, but
they still not telling you what an old mammal brain is.
All right, hold on.
Old mammal brain in humans.
What is a old mammal brain in humans? See if we can get some off of it. But I have to put my damn good glasses on. Hold up. See.
So while he's doing that, so what we're showing y'all is the brain is part reptilian, part mammalian. It's got two parts of it, old mammal and new mammal brain that overlays the reptilian brain.
Yeah, it says right here, the mammalian brain is known as the intermediate or old mammal brain. The mammalian brain anatomy consists of the hippocampus and the hippocampus and the can't see that. It's responsible for the subconscious emotions such as fear, joy, fighting, and sexual behavior. Hold on, let me get this one. The reptilian brain at the core is responsible for the arousal, the reproduction, mammalian, old mammal brain surrounding and is involved with learning, memory, and emotions.
So you're seeing what these parts of the reptile brain do, what the old mammal brain do. Now you have the new mammal brain, like just put in what it take out old and put in new.
Okay, all right. Boom.
All right, go back to the beginning so we can read what it say.
All right. The Olympics brain emerges into the first mammal. It can record memory or behavior that produce agreeable and disagreeable experiences. So it is responsible for what are called emotions in humans. The main structure of the limbic brains are the hippocampus and the I can't pronounce that word. It's gorda and the hypothalamus.
Hypothalamus.
The hypothalamus. That's what it said.
Mm-hmm. So now you got 3 parts to your brain. They showing you what your reptile brain do, what it's responsible for, what your old mammal brain do, what it's responsible for, and what your new mammal brain do, and what it's responsible for. Mm-hmm. Right? Now, so this goes back to when Malachi say we are part human, part reptilian. We're a reptile human hybrid. Mm-hmm. But let's get a little deeper. This is where we wanted to go today. Mm-hmm. Right? So now we looking at the physiology of the central spinal system. And now we looked at the brain, but we want to go deeper because what the human is at its cellular level is even more interesting than what they is at the physiological levels here. Mm-hmm. Right? So if you pull up the DNA helix.
DNA, it's like a spine too.
Now, it kind of look like it, don't it?
Yeah.
Now look, the DNA helix right there is in the process of what they call replication. That word replication is important. Mm-hmm. Half of the DNA helix, when it's separated, is called RNA. Mm-hmm. So you see it separating, it's showing you the RNA. Now, if you look behind the DNA, you see all those little fragments.
Yeah, like screws.
Yep, those are called free radicals. Where they come from? Yeah, you see what look like ladder legs between the DNA helix that separate? If one of them break, it flies around like that.
Okay.
That causes what you call the mutation. Because the 2 RNA now have to come back together to form a DNA helix. Right? So when it come back together, if one of them is broken, that causes a degenerate cell. But there's something that you can do. You can take amino acid supplements because those are made of amino acids. Right? When they in that free radical state, they in a dead state, and it causes problems if they latch on to the wrong part of a DNA helix by themselves in that state as a free radical. Right? Now, if we go into what the DNA is composed of, pull up amino acids.
Right, I got you. Amino acids. Is that what they call them? Protein?
No, protein is different than an amino acid.
Amino acid.
Go to the main page so you can read what it say it is.
Amino acid. I got you. It says amino acid is a molecule that combines to form proteins. Amino acid is a protein or a building block of life. When proteins are digested or broken down, the amino acid are left. The human body uses amino acids to make protein to help the body break down food.
Okay, now they're not telling you that the DNA is made up of amino acids. All right, so it's 21 complex amino acids. They are what you call a crystalline substance. Put the word crystalline in so they can get the definition.
Having a structure or form of crystals composed of crystals.
Right. Okay, now, write crystalline there and write structure of DNA.
All right. Oh, baby. All right. DNA molecules consist of two separate strands that spiral around each other to form a structure called the double helix. Each strand contains repeated units, with each unit consisting of a phosphate group and a sugar molecule bound to one of four basics. The two strands are held together by bonds between the bases. DNA crystals form which a double helix is suspended in the liquid and evaporated. They grow in patterns depicted by the information stored within the strand. Seen in a cross parallel light, they display a mind-blending kaleidoscope of colors and shapes. The huge range of crystal structures is amazing.
Okay, now we talking about DNA.
Picture of it. Okay.
Yep.
I just thought about something, man, too, while we looking at this, that our DNA is really crystals, you know.
That's where we going with this.
That's another look. Let's see. Let me pull up a picture of this, man. See, can we get something going right there? Because I studied nucleic acids, like the nucleic acids, same thing as amino. So DNA and RNA is based on amino acids. Yeah, that's good. That's good stuff. I want to see what you got on this, man. This about to get deep out there. All right, this is a picture of it right here.
Okay, blow it up, because the next picture I'm gonna have you pull up is nanotech.
Okay, all right.
Okay, now right here, the DNA is doing something, but we can't tell what it's doing because it's a still picture. Right? But it's forming what they call peptide bonds to hold them together. Now remember, these are crystals. Right? So pull up nanotech.
I got you. Nanotech. Come on, baby. Come on. All right. I think you looking probably for either one of this picture. Which one you looking for?
Let's go to the definition of it. That's nanotech right there.
Okay, all right, I got you. Come on. Okay.
We're going to the definition on the first page.
Nanotechnology is a science engineer. Okay. Let's see. It says, okay, all right. Nanotech. Nanotech is a term given to those areas of science and engineers where phenomena that take place at dimensions in the nanometer scale are utilized in design, characteristics, production, and application of mineral structures, devices, and systems. It also says right here, nanotech is a science engineers technology conducted as a neural scale, which is about 1 to 100 nanometers. Let me see if I can find it.
Okay, now we got the size for a range from 100 nanometers.
Yeah.
All right, let's see what the size of a DNA helix is.
All right.
So the question is, how big is how big is DNA helix?
All right, I got you. Let's see.
Gotta go to the first page.
That's what I'm doing. This damn computer right here, man.
Oh, just running slow?
Yeah, double and I cleaned it off too, man. I'm telling you, the double helix looks like a twisted ladder. Okay, I'm looking for the size. What the size? Hold on. Here we go. I think I typed it in wrong. Here we go. We're getting up. Hey, close my door for me, baby. All right, it's 2 nanometers. The diameter of a DNA helix is 2 nanometers, and the vertical rise per base part is 0.3 nanometers.
Right. So you see how small that is compared to nanotechnology. We in the nano scale.
Yeah.
Okay. So now